Welcome everybody to another Kuta worksheet tutorial by Mr. West. Today we're doing polygons and angles. So the first set of questions talks about interior angles of a polygon. So we're going to kind of break it down first into what is an interior angle of these polygons, and we're also going to encounter exterior angles, so we'll kind of start there. Now, when it's talking about interior and exterior angles, well, first we're talking about a polygon. A polygon is a 3 or more sided shape, enclosed shape with at least 3 sides. Okay, you can't have a 2-sided shape in case you're wondering. But anyway, when we're talking about interior versus exterior, what we can do is we can extend a side here like that, and it creates a line with 2 different angles. So we have this angle right here, okay, and then we have this angle on the outside of the shape. So that's obviously the exterior angle. And then the one on the inside of the shape is the interior angle. So that's the one we're talking about when we're talking about the interior angle. Okay, now it says find the measure of one interior angle of each polygon. The equation your teachers are probably going to give you is the sum of interior angles. That means all of them added together. Okay, the interior angle sum theorem is what it's derived from, and I'll give that to you in just a second. So this is all the angles added together. Okay, let me draw an arrow in case you didn't know. And we're going to say is equal to the number of sides minus 2 times 180 degrees. And that will be the sum of the interior angles. For a 5-sided shape, we would say that, well, let me highlight here just to make it cool. 1, 2, 3, 4, 5. Look at that expert drawing. So we'd say n equals 5. It's a 5-sided shape. If we wanted to find the sum, we'd do 5 minus 2 times 180. And I think that's 540 because we get 3 times 180. That gives us 540 degrees. So the sum of the angles equals 540. That means that these 5 angles that we don't know the value of, we can call one x, and there's 5 of them. So we have 5 angles times x is going to be equal to 540. Okay. Now, if we just want to find what x is, one angle, then we would divide both sides by 5. Okay, let me get my calculator out here. 540 divided by 5, and we would get 108. So x equals 108 degrees. And that's how you do these types of problems. It's not complicated. It's kind of a lot of like button pressing on a calculator, but really it's not bad. So this kind of leads us to our formula for each interior angle. So if we're just looking for one interior angle, now let's use blue. Each interior angle of a polygon, interior angle, we would use the following formula. So we're going to use the sum, okay? And what is the only thing we did differently? So we had the sum, and then we just divided by the number of sides. Number of sides. What is that represented by? Well, we already said n. Let me write this. Yeah, I'll write it over here. N equals the number of sides. I don't know if I said that earlier. I think I said it. I didn't write it. So we just divide by the number of sides, and there you go. This is for one interior angle of a polygon. So if you're not looking for the sum, you're going to use the one on the left. If you're looking for the each measure, then you're going to use the one on the right. And that's how you do these problems, okay? Now, we can easily apply it to any of these ones. So if we're looking for this guy, number 5, for example, you're going to use the same formula each time. N minus 2 times 180 divided by n. Okay, so in this case, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 sides. N equals 9. We plug that in. 9 minus 2 times 180 divided by 9. And that's 7 times 180 divided by 9. You might hear my calculator typing. You might not. And this is each angle. So in this case, we got that each angle equals, or one angle, if you want to think of it that way, equals 140 degrees. Okay. What else can we say about this? To find the measure of each of one interior angle, round your answer to the nearest tenth if necessary. And that's really all there is to it. Now, one thing that's important is, and it doesn't say, because it is important, this only works for regular polygons. What does that mean? Well, regular polygons are polygons that have equal angles and equal sides. So if it doesn't have equal angles, then one angle might be 140 in this problem, one might be 90, one might be 200, okay? But this only works for regular polygons or equiangular. All the angles need to be the same in order for this formula to work. So just keep that in mind. All right, now we're going to move on to exterior angles, just because all these problems are going to be the exact same formula. Use these formulas. They're all regular shapes, blah, 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 blah. Okay. Now we're moving on to exterior angles. Okay, exterior angles. Now, with exterior angles, the formula is much more simple. All the angles of the angle sum, the exterior angle sum for any polygon is always equal to 360. Okay, I talk about that in my other video. It's the, I think it's, what is it, 6.1 notes. It talks about how you add, even as you add the number of sides, it looks more and more like a circle. So this one's starting to look like a circle, and as we know, circles have 360 degrees. So the exterior angles are these ones right here, and as you add an infinite number of exterior angles, then it's going to become a full circle. But even still, let's take a quick shape like a triangle like this. Okay, a triangle like this. If this is equilateral, these are all 60, and then these are all supplementary to that. These are all exterior angles, so that's 120, 120, 120. That adds up to 360 for the exterior angles. So that's like the cool thing. We know all the angles equal 360. So to find each angle, let me highlight this so you guys can see it more clearly. So exterior angle sum equals 360. I kind of messed that up. Let me go again. Try again. All right, okay, there we go. Now, each exterior angle, what's the difference? Well, we just want to find one. Each exterior angle equals 360, and then we divide by the number of sides, or the number of angles. And the number of sides is always equal to the number of angles for polygons. Okay, so this is pretty straightforward. For example, we can try it on, I guess we were working on 11, we might as well finish it. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 sides, so 360 divided by 10, and that's going to give us 36 degrees for each exterior angle. Something like this, we have 1, 2, 3, 4, 5. We have 5 sides, so n equals 5. We do 360 divided by 5. Oh boy. Should know what this is. 360 divided by 5, it's going to be 72. So 72 degrees for each exterior angle. So that would be 72 degrees because we got to extend the side. I did a perfect job of that. Okay, and the same thing is going to be applied to all these. You're going to be using this formula on the right for all these problems in this section. Okay, last section, I think, besides the critical thinking ones, find the interior angle sum for each polygon. Okay, this is the first formula I talked about. So I'm going to copy paste it. Okay, I'm going to get some other stuff in there too, unfortunately, but I'll be able to delete it. Okay, so we're just going to use the sum of each one of these. So, for example, this guy's got 1, 2, 3, 4, 5, 6, 7. This has 7 sides. We have n minus 2 times 180. That's going to be end up 5 times 180. All right, and this is going to equal the sum, and that is 900. Tony Hawk. Hopefully you guys know who Tony Hawk is. So that equals 900 for number 21. All of these you're going to use the same formula. You just plug it in, the number of sides. Make sure you count the number of sides correctly. 18gon, that means 18 sides. Regular dodecagon. Dodecagon, I can't remember. I think that's 20 sides, or dodecagon. That's 12 sides. Okay, so just in case you were wondering, I can never remember. 12 sides for that one. Regular quadrilateral, that's a square, that's 4 sides. So just make sure for these ones you know that this, when it says 23 gons, it's 23 sides. Same thing with all these ones, okay? So that's like the main deal with this one. 500 gon, what is, let's cover these critical thinking questions. What is the exterior angle sum of a 500 gon? It doesn't matter how many sides it has. The exterior angle sum, as we suggested earlier, okay, the exterior angle sum is always what? 360. So this is like a trick question making you think that's hard, but it's really not. Is there a regular polygon with an interior angle sum of 9,000? Well, we can find out. What we can say is interior angle sum. That's this formula right here. Guess what we're going to do? We're going to copy paste it again. So copy, paste. Hopefully, if you don't need this section, you can just skip it. So see you next time. But I'm going to finish this off real quick in case you're still watching. Hopefully you're still watching. So the sum we know is 9,000, so we're going to plug that in for sum. We're going to set it equal to this, and then we're going to solve for n. This is a pretty common type question, especially on a test. And then what you do is you solve for n. So you have to divide by 180 first. Okay, so 9,000 divided by 180, and we get 50. So 50 equals n minus 2, and then you just add 2 to both sides, and you get n equals 52. So a 52-sided shape has an interior angle sum of 9,000. So there you have it, your introduction into polygons and their angle sums. Hope you enjoyed this video. Thank you so much for watching.